short form, using your initials, the names of elements are written using symbols. The symbol is the first letter or the first two letters of the element's name, or the first letter and another letter of the element's name. The first letter of a symbol is always a capital letter, while the second letter, if there is one, is always a smaller letter. The symbols for some of the elements are derived from the element names in Latin, Greek or German. For example, the symbol for iron, Fe, comes from iron's Latin name, ferrum. The symbol for tungsten is W from the German word wolfram. The names for all newly discovered elements are now approved by the International Union for Pure and Applied Chemistry, the world body that standardizes naming of elements, compounds, and so on.
Writing chemical formula using valence. A chemical formula is the symbolic expression of a compound. Formulas denote the actual number of atoms present within a compound. The chemical formula may be used in chemical equations as a representation of chemical reactions. The valence of an atom is the number indicating the electrons in an atom that take part in chemical bonding. The rules of valence. Atoms of group 1A have valences of +1. These elements are lithium, sodium, potassium, rubidium, cesium, and francium. Atoms of groups 2A have valences of +2. These elements include beryllium, magnesium, calcium, strontium, barium, and radium. Oxygen has a valence of -2. Fluorine has a valence of -1. Hydrogen has only one electron, so it can have a valence of +1 or -1. Radicals are groups of atoms that frequently appear in compounds. They have a valence associated with the particular radical. Let's walk through the procedure for writing chemical formulas using sodium fluoride as an example. First, determine the valence of each chemical in the compound. Sodium is a member of group 1A, therefore the valence is +1. Fluorine has a valence of -1. The next step is to write the cation, the positively charged atom, on the left, and the anion, the negatively charged atom, on the right. The formula is written by crisscrossing the valences and making them subscripts. More precisely, the chemical formula for sodium fluoride is written as NaF because ones are not written as part of the formula. Consider a second example. Calcium phosphate. In this compound, the calcium ion is a basic radical and the phosphate ion is an acidic radical. The calcium ion has a valence of 2. The phosphate ion has a valence of 3. Write the cation on the left and the anion on the right. Crisscross the valences. Polyatomic radicals must be enclosed in parentheses. The phosphate ion is a polyatomic radical, meaning it must be enclosed in a parenthesis with the subscript written outside. The final formula of calcium phosphate is written as Ca3PO4 2. Summary. Writing the chemical formula of compounds on the basis of the valences involves identifying the anions and cations. The valences of the respective chemicals are written as subscripts and they are exchanged with one another. The atoms of the polyatomic radicals are enclosed in parentheses.
Matter exists as pure substances or impure substances. Pure substances are further divided into elements and compounds. A molecule of element or compound is formed by the combination of same or different elements. Formulas are used to represent these molecules of elements as pure substances or impure substances. Pure substances are further divided into elements and compounds. A molecule of element or compound is formed by the combination of same or different elements. Formulas are used to represent these molecules of elements. An element is composed of the same type of atoms. Sodium is an example of element. Hence, the smallest part of element which each molecule is made up of is definite number of atoms. The number of atoms in the molecule of an element is called its atomicity. Observe the elements of helium, potassium and calcium. All these elements contain only one atom. Hence, molecule of an element containing one atom is called monoatomic molecule. Now observe gases such as oxygen, hydrogen and nitrogen. All these gases contain two atoms made of same element. Hence, molecule of an element containing two atoms is called diatomic molecule. Now observe the element ozone. It has three atoms. Hence, molecule of an element containing three atoms is called triatomic molecule. The table on screen lists the formulas of molecules of few elements on the basis of their atomicity. We have learned that a compound is made of more than one type of atom. Water is an example of a compound. Two atoms of hydrogen combine with one atom of oxygen. Hence, it is represented as H2O. The atoms combine with each other in whole numbers. It is called the combining capacity of the elements. Therefore, the whole number ratio in which the hydrogen and oxygen atoms combine is 2:1. Thus, the combining power of hydrogen is 1 and that of oxygen is 2. Let's now write down the formula of the compound calcium chloride formed by combining two elements calcium and chlorine. In the first step, write the symbols of calcium and chlorine, which is Ca and Cl respectively. In the second step, write the combining power of each element under the symbols. The combining power of calcium is 2 and chlorine is 1. Now interchange the combining powers of the elements to obtain the chemical formula. The chemical formula we get from the compound is calcium chloride, whose formula is CaCl2. In a similar way, we can write down formulae for other compounds also. Let's recap what we have learned.